Alright, let's do 3-sum. You guys ready? Okay. So 3-sum is trying to get 0 solution for a combination of 3 numbers in an array. So what we're thinking about doing is we could do something similar to 2-sum. So what happened is 2-sum is using this technique where we have value to it's a index no, it's complement key complement to value index. This is the mapping that we use for 2-sum. So if we do the similar thing for 3-sum, we extrapolate this technique such that you have a complement, then you have 2 values. Value index of 2, let's see. 2 indices. So it's a complement to 2 indices. Value indices. This would be complement O of n times complexity. Base being of n equal with the mapping. You can cover the entire array of values before you could find the value that you want. Put all of that in the mapping, and that would be space of O of n. In this case, it would be O of n squared sum space O of n. Because you'll be doing the same thing as 2-sum, but you could, if you have it 2 value indices instead of 1 value indice for a complement. That should, at least that's the, I'm not sure if this is right, but to test this hypothesis. This is the hypothesis. Alright, let's see if it works. So yeah, we do 1, -1, 0, 1, 2, 1, 4, and we're trying to output is it possible that we have multiple of the same complement? Essentially, it's, yeah, that'd be with multiple answers. Is there only one? Okay, let's see. As output, there could be multiple. Yeah, let's see if we can do that. All right. So we'll have init, all initialized variables. And it's over to the left. Okay, and that would be input nums. then we'll have the mapping. So we knit the map, and we'll loop through. If, or we'll get the complement equals. We'll have, it should be nested loop, so that we can get two indices. Or we would do one loop with one pointer here and another pointer here. Or one loop with one pointer here and one pointer here. So we do 2 pointers like this. Let's see. Maybe three pointers like that. So you got 3 values. Then you could move this down. Yeah. Yeah, if we do this such that it goes here, then we'll have another value that goes from here to the end. And then we move the pointer here, there's a value from here to the end. Then we'll go here, so value to end. Then we'll have all the combinations. So you'd be looping with 1 and 0.2, 0.01, 0, 2, equals 1 to end. So pt.1 plus 1. Okay, this is the loop. P2 equals P1 plus 1. And it goes to the end. So this goes from 0 to n, goes from 0 to n as well. Or what, it goes from 1 to n. So that's n squared. And then update map. How do you want to update the map? So you add the value, the complement to in the C mapping, and that for everything else. Now towards or okay, check if in map. And then we'll return if map. Else we update map. And we return. Okay. So that'll be our logic here. Let's try running through it, right? So first value is -1, 0. So 1, so 0, 1. So right now it's 0, 1, and the mapping here will be, since we're trying to get equal to 0, it'll be -1 is, no, -1 plus 0 is -1. -1 plus 0 is -1. Then complement is 1 minus -1 equals 2. So 2. And then we check the next value. So we check -1 and 1. What will we do with that? So -1 and 1. Then we need 1. We add 1 to the mapping. So it'll be 0, 2. And then go to that. -1 and 2. And that equals 1. So we need a 0. So 0. 0, 3. And then -1. So -1 and -1. -1 plus 3 is, wait, plus 2 is 0. Wait. I think I did it wrong the first one. So it's -1, 0. You need +1 to reach 0. So let's just restart. It makes it so much. Let's restart. Okay, so -1 plus 0 plus 1 equals 0. So 1 is the complement. Or 0, 1. X 0, 1. Now go to this. So it's 1 minus 0. So that's 0. 1 minus 1, 0. 0 plus 0 equals 0. So 0 divided by 0. That'd be 0, 2. And then over here, we need a 2, 1, you need a -1 to make it a 0. So 2 minus 1 plus 1, you need a 2 minus 1 minus 1 equals 0. Then it would be 0, 3, 3. Now, go here. -1 minus 1 plus 2 equals 0. Now we do the same thing for this. -1 minus 4. 0. That'll be positive 5. Negative positive 5 to make it 0, so 0, 5. Then we shall move to the next value, this 0. Yeah, we can't return if it's in the map though. Okay, so what I realized is if we return in the map, if it's in the map, there might be other solutions. So we can't just return. We add to return array if exists, if in map. To be init map, then output see which is the triplets. Return triplets. And we'll return triplets. Here. Should be it. Okay. So 0, 1. Place it at end. 0, 1. Yeah. It should work. So 0, 1 is -1. So 1, 2, indices 1 and 2, we add to -1. Now 0, 2, -2, 2, I think we had to. Sorry, one more round. We forgot to add to the return array. Return triplets. Okay. Okay, we start from the beginning here. One last time. Third time's a charm. So 0. So 0, 1, 0, -1, 0. -1, 0. So that's, oh, it needs a positive 1. So 0, 1. Now goes, checks to see, does -1 exist? Oh wait, what would it check? Which value would it check? It has to check the first value, right? Oh, maybe, yeah, okay, so it checks -1 first. Is -1 in the map? Hmm. The issue with checking to see if -1 is in the map first is you could have, it might have a duplicate indices. We don't want that. We don't count first and twice. So I think after, yeah, so if we have a pointer that points to the previous value, so previous value is empty. So if you have a previous pointer, and we have to make sure that the previous pointer is, yeah. So how do you make sure that we are not using any of the frequencies by having a value before it? Yeah. So we have first triplet.